My project is on Dr. Karen Ashe and her contributions to Alzheimer's research. Dr. Ashe was born in 1955, where she grew up in St. Paul and attended St. Paul Academy and Summit School. Her interest in the brain started here, where she excelled in math and music. She earned her undergraduate degree in chemistry at Harvard University in 1975. She enrolled as a sophomore at just 17 years old. She completed her PhD in Brain and Cognitive Sciences at MIT in 1981 and earned her MD from Harvard in 1982. She joined and is still with the University of Minnesota Medical School in 1992 as a professor in neurology. She founded the N. Bud Grossman Center for Memory Research and Care. This is where she does most of her research, and they've received $28 million in grants for their work from the National Institutes of Health. She researched with Stanley Prusiner, who gave her credit towards his Nobel Prize. Dr. Ashe was personally credited with discovering a mutation in the PRP gene. As a neuroscience major at the University of Minnesota, I feel a strong connection to Dr. Karen Ashe's research. Her work on Alzheimer's disease and memory loss directly relates to what I study in my courses, especially when learning about how brain structures and molecular changes affect behavior and cognition. I admire how her discoveries combine neuroscience with real-world medical applications, showing how research can lead to meaningful change in patients' lives. Her studies on the toxic protein amyloid beta star 56 and its role in memory impairment highlight how small molecular changes can have a major impact on brain function. There wasn't too much information on her personal interests, but she has a lot of work-related interests. She uses genetically engineered mice to research memory loss as a side effect for dementia. She looks at how it visibly spreads in mouse brains over time, and specifically the effects on brain cells. She is currently broadening her research on which key proteins, such as caspase-2, contribute to different types of dementia development. She is also researching what proteins are harmful in mouse and human brains based on shape, size, or chemical composition. She has personally trained more than 40 scientists. She has a lot, but her biggest awards is that she has won a Potemkin Prize in 2006, an election to the National Academy of Medicine in 2009, and a MetLife Foundation Award in 2005. Her favorite quote is right here at the bottom. Here is a graph from her most recent discovery. On the x-axis, there is the type of mouse, and the N is the amount of mouse per that group. TG means the transgenicness. On the y-axis, there is the percent of mice with the amyloid beta star 56 entity. This shows that the dementia-causing entity increases with age and becomes nearly universal over time. Mice that are non-transgenic, younger than 6 months, or are regulatable transgenic do not have this entity. For Dr. Ashe and her team to prove that this entity causes memory loss, it was taken from old transgenic 2,576 brains, immunopurified, and injected into the hippocampus of healthy mice. These mice had significant memory loss over time. Dr. Ashe's work has uncovered that amyloid beta star 56 is real, stable, and memory impairing by viewing and running tests on the brain at different times after injecting it into healthy mice. She did lots of parallel tau pathway work, found that lowering caspase-2 tau fragments restored synaptic function and reversed memory problem in mouse models. There are early human signals that exist, as her work shows that there are 2.9 times higher amyloid beta star 56 levels in nasal fluid of people developing Alzheimer's. She discovered that the enzyme caspase-2 cleaves tau protein into a toxic tau fragment that leads to memory deficits. She also was able to lower caspase-2 levels and block the toxic fragments, which restored connectivity and reversed memory loss. The next steps for Dr. Ashe and her team are to test antibodies that reduce amyloid beta star 56 levels in mice. She is focusing on the areas with cerebrospinal fluid, plasma, or nasal samples. She also plans to improve the antibodies to better distinguish amyloid beta star 56 from other oligomers. Dr. Karen Ashe's discoveries have reshaped how we understand Alzheimer's disease. Her work revealed that proteins like amyloid beta star 56 and toxic tau fragments can directly impair memory. These findings not only explain why plaque levels don't always match symptoms, but also point toward new, earlier targets for therapies that may one day slow or even reverse cognitive decline.